In this lesson, we're going to take a look at graphing exponential functions using transformations. In our previous lesson, we learned about what h and k do in terms of moving the graph around, and today we're going to look at what happens when you put a number in front of your exponential base and multiply. So we're going to start with the first one here. It does say to create a table of values and to round to 2 decimal places. So I'm going to start with y equals 2 to the power of x. And this one I am not going to use decimals on. I will never use decimals on my original base function. And I know that this is the original base function because I notice that every single one of these also has a 2 to the x. So I'm going to start with the first one, make our table of values. We've actually done 2 to the x. I'm going to zoom several times before. This is not the first time we've seen this. So 2 to the power of x, I always like to start at the bottom. So I'm going to do 2 to the power of 4, which is 16. 2 to the power of 3 is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0, anything to the power of 0 is not 0, it's 1. 2 to the power of negative 1, so I've got a negative exponent. A negative exponent makes a fraction and it has a flipping over action. So what I do is I take a look at 2 to the power of 1, which is 2, and then I flip that over to make it a fraction, which would give me 1 over 2. 2 to the negative 2, I'm going to look at the positive 2, which is 4, and flip that over to make a fraction of 1 over 4. Negative 3 is going to be 1 over 8. And negative 4 is going to be 1 over 16. Okay, so what we want to do is very quickly plot that on our graph. I like to start with the larger values at the bottom and then work my way up to the fractions because they are a little bit harder to graph. So I'm going to do 4 and 16, but I find it easier if I mark some form of a scale on first. I think I'm going to do 5s today. -5, 10. We'll go from there. Okay, so I've got 4 and 16 is my first point, so I'm going to find 4 on the x-axis and 16 on the y-axis. So there's 4 and 16. And then 3 and 8, 2 and 4, 1 and 2, 0 and 1. And then the tricky part, the fractions. So negative 1 and 1/2, which is about half a square. Negative 2 and 1/4, which is half of what's left. And then negative 3 and 1/8 just keeps getting closer to 0 there. And 1/16 is even closer. So when I draw my exponential, we will have one side that looks kind of like a parabola with an arrow on the end. Make sure you do your arrow all the way to the end of the grid. And then on this side, it just keeps getting closer and closer and closer to 0 because there is a horizontal asymptote there. Okay, so let's try the next one. I have y equals negative 2 to the x. So what I'm going to do here is I'm not going to recalculate using my calculator. I'm just going to take all of the numbers I had for 2 to the x and I'm going to times them by negative 1 because that's really what's going on here is we're multiplying by negative 1. So 16, I'm going to start at the bottom, times negative 1 is negative 16. 8 is going to be negative 8. 4 times negative 1 is negative 4. 2 times negative 1 is negative 2. 1 times negative 1 is negative 1. 1 times 1/2. Now at this point, if we wanted to make it a decimal to make it easier to graph, that would be okay. That's going to be 0.5, so this would be negative 0.5. You can use your calculator, and I will pull out the calculator when we do the next one. Negative 2 times 1/4. 1/4 is 0.25. So let's try here. So 1 divided by 4 times negative 1 is going to be negative 0.25. Okay, 1 divided by 8 is 0.125, so that's going to be negative 0.125. And 1 over 16 is 0.0625, so it's going to be negative. Now I did say to round to 2 decimal places, but since it's such a nice rounded decimal, I'm just going to keep it because it's already nice and exact and I like it that way. So we're going to very quickly plot those points down at the bottom. Take a look at what's happening. So I've got 4 and negative 16 this time. So 4, I guess I should have marked my scale all the way down. I didn't think I'd need it. So 4 and negative 16 is there. 3 and negative 8. So 3 and negative 8. 4 and negative 4. Okay, I take it back. This is not negative 8. Negative 8 would be right there. Wow. Plotted a whole bunch of points wrong. All right, 2 and negative 2. Okay, I think I'm going to need to pick a different color because I think I made a lot of mistakes here. All right, so let's try one more time. So I've got 4 and negative 16, which is okay. And then 3 and negative 8, which is okay. And then 2 and negative 4, which was okay. And then 1, here we go, and negative 2, 0 and 1. Sorry, negative 1, negative 1 and negative 0.5, negative 0.25. Negative 0.125, 0.0625. Sorry about the confusion on that. So there's my parabola-ish side. And then my asymptote for this one is actually also going to be 0. It's just it's coming at it from a slightly different side. So I was trying to color code these. I'm just going to mark that I ended up doing this one in that color instead. Okay, so let's take a look at the next one. We're going to do 2 times 2 to the power of x. So I'm going to take the values for 2 to the x, and I'm going to just multiply everything by 2. So I'm going to start at the bottom, it's a little easier. 16 times 2 is 32. 8 times 2 is 16. 4 times 2 is 8. 2 times 2 is 4. 1 times 2 is 2. 1/2 times 2. Now I can use my calculator for that if you're not sure what that is. So 1 divided by 2 times 2 is just 1. 1 divided by 4 times 2. Oops, I can't see that. Oops, let's try that again. So it was 0.5. 1 divided by 4 times 2 was 0.5. And then 1 divided by 8 times 2 is 0.25. Definitely seeing a bit of a pattern here. I noticed that the numbers match these ones here, except they're kind of off by 1. And 1 divided by 16 times 2 is 0.125. Okay, so we're going to plot them down here on the graph. It's going to get pretty busy once I get all of these on here. So 4 and 32, my graph doesn't go to 32, it only goes up to 20. So I can't actually graph that one. The next one is the 16, so I can't put that on, but I can do 16. So 3 and 16, I'm going to go to 3 and 16, 2 and 8, 1 and 4, 0 and 2, -1 and 1, -2 and 0.5. It's getting a little messy down here. And then 0.25 and 0.125. And you're going to notice you're starting to see a little bit of a, not an overlap, but the asymptote parts are getting really close together because they all seem to have the same asymptote here. So I'm going to draw in the parabola side. Well, it's not really a parabola, but it kind of reminds me of one. And the other side. Now, if you're not color coding, you really should maybe number the graph. So like this would be graph number 3, and then put a 3 next to it. But I was trying to color code so that hopefully I don't have to do that. Now I'm going to ask you to take a second and pause the video and do the same thing that we did, but multiply by 5, please. Try it yourself. All right, hopefully you did actually stop the video. I've already worked out the values for this. So I've already got all of my points. Unfortunately, it's in a color I've already used, but it was the color I made the mistake in, so we can actually use it. So I've got all my values. What I did was I just took all those numbers and times them by 5. So I'm going to plot them on the graph. So 4 and 80 is not going to fit. 3 and 40 is not going to fit, but 2 and 20 should fit. So I'm going to mark on 2 and 20, which is all the way up there at the very top. 1 and 10, 0 and 5, -1 and 2.5, so that's going to be 2 squares and then a half. And then 1.25 should be a little bit above 1. And then 0.625 is going to be a little bit below 1. And then 0.3125 should be less than halfway, but it's getting a little messy with all of the asymptotes that are sitting there. So I'm going to mark on the one side, and then the other side. At this point, it's really just becoming a mess of marker that's all overlapped. So that's graph number 4, if you're labeling, or it's going to be my new red one. A little 4 at the top there. Okay, so we're going to do one with a fraction, and then we're going to take a look at the last one I'm going to ask you to try on your own. So I have 1/2 times 2 to the power of x. So I'm going to take all of those 2 to the power of x values and times them by 1/2, or divide them by 2, or multiply them by 0.5. I think I'm going to divide by 2 when I do it on my calculator. So the first number here, I can't really see them anymore. I can if I kind of fold my page over, which I really want to do. You can kind of read your numbers and then do it that way, but I'm just going to read off my sheet, so hopefully you can see them on your sheet. So 16 divided by 2 is 8. 3 divided by 2, sorry, not 3, 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2, or 0.5. 1/2, or 0.5 divided by 2 is 0.25 if you use your calculator. Maybe I should show you that. So if you do 1 divided by 2, divided by 2, I get my 0.25. If I do 1 divided by 4, divided by 2, I get 0.125. And then if I do 1 divided by 8, divided by 2, I get 0.0625. And then 1 divided by 16, divided by 2, is 0.03125. And then I am going to very quickly plot that. So this will be our graph number 5. So I start with the numbers I can actually see first of all. So 4 and 8. So 4 and 8 would be there. And then 3 and 4. 4, sorry, nope, 2 and 2. 1 and 1. 0 and 0.5, and then 0.25, and then those are just going to get lost down in there. So I end up with this side of the graph going like that, and then the rest of it leveling off in that big mess of marker that I've got going on. So this is graph number 5. And then what I would like you to do is to take a look at the last one. Okay, to plot it yourself, to calculate your values, what you're going to do for this one is you're going to divide by 5. So you're going to take all the numbers for 2 to the x and divide them by 5. So in the next part when we come back, you can check your numbers, but I'd like you to do that yourself, please.